Happy Friday, everyone. Today will be the last, today we're going to review the final exam for 0324 and 1324. And here are the topics that I'm going to cover today. They're called linear equations, quadratic equations, applications on linear and quadratic functions, exponential functions, applications on exponential functions, solving exponential problems, finance applications, solving systems of equations, matrices, sets and Venn diagrams, probabilities and permutations and combinations. So first, let's start with linear equations. Number one, find the equation of a line passing through the point -2, 5 and -4, 6. So here we first have to find the slope and also the y-intercept. They want the equation in slope-intercept form, which is y equals to mx plus b. So the slope m is equal to y2 minus y1 over x2 minus x1. So we have to let point 1 be x1 and y1, and point 2 be x2 and y2. Okay? So we know that x1 is equal to -2, and y1 is 5. x2 is x2 is -4, and y2 is 6. So we plug them into the formula. So we get 6 minus 5 over -4 minus -2. That will give us -1/2. Okay, now, so now we must choose another point. It doesn't matter which one. In this case, I'm going to choose the -2, 5. So b equals to y minus mx. So my y is 5 and my x is -2. And my slope is -1/2. Will give us 1, -1, and then negative. This has to be, this is going to be positive here, guys. There's a mistake here. This is supposed to be a 6 because 5 plus 2 will give us 6. So this is supposed to be a 6 here. My bad, guys. So the answer should be y equals to -1/2 x plus 6. And again, my slope, hold on, guys. My slope is -1/2. I forgot to put the 1/2 here. No, this is correct because if the slope is -1/2 times -2 is going to give us a 1. And 5 minus 1 is 4. This is correct here. The mistake here was that my slope is -1/2 and I didn't put -1 here. I apologize for that. Now, number 2 is find the difference quotient. The difference quotient is f of x plus h minus f of x over h. So here we have the function f of x equals to x squared minus x plus 4. So the solution is we first must find x plus h, f of x plus h. I'm going to go to my original function and I'm going to plug in x plus h for every x. So I'm going to plug it in for the x's are, so it'll be x plus h squared minus x plus h plus 4. If I do the FOIL or multiply x plus h and x plus h, it's going to give us x squared plus xh, because x times x will give us x squared, x times h will give us xh, and then h times x will give us xh, and h times h will give us h squared. We combine like terms, so it's going to give us x squared plus 2xh plus h squared. So I'm going to replace the x squared plus 2xh plus h squared for the x plus h squared, and then minus my x plus h plus 4. So with the minus here, I'm going to distribute the sign, or the -1, which will give us -x minus h plus 4. And we combine like terms, right? Nothing can be combined because there's nothing that's the same. So then the second step is going to be f of x plus h minus f of x. So I already got the f of x plus h. Now minus the f of x is the original function, which means that we're going to bring down the f of x plus h, and then minus f of x, I'm going to distribute the negative sign, or the -1 times x squared will give us -x squared. -1 times -x will give us positive x. And -1 times +4 will give us -4. Now we're going to combine the like terms here. But here's like a hint. Every term that doesn't have an h must cancel. So for example, x squared doesn't have an h, so there's going to be, and I put here the hint. So x squared and the negative x squared, they will cancel. Okay, now 2xh, right? There's no other term that has a xh, so so that one stays. The x doesn't have an h, so negative x, and the x here on the right side is going to cancel also. And the 4s will also cancel because they don't have an h. Or we combine like terms, they'll cancel. But like I mentioned here with the hint, and this is what I tell my students, that every term that doesn't have an h will be eliminated. And that's what happened here. Now what's left will be 2xh plus h squared minus h. Now I'm going to factor out an h. What's the purpose of this? Because when we do the difference quotients, we have the f of x plus h minus f of x over h. That way, the h on the denominator will cancel. You see, for example, this is what I'm talking about. So these will cancel. So my result will be 2x plus h minus 1. This is my result here. And the difference quotient, you will see it again when you take the 1325 course, which is almost equivalent to Calculus 1. So if you're taking if you're going for business or for accounting, you will see this again. Now number 3. Number 3 says the manufacturer's suggested retail price, MSRP, for a base model 2016 Toyota Prius is $25,035. And it is expected to be worth $14,115 in 4 years. So this is like a three parts for this question. The A part is find the linear depreciation function for this car. The B part is estimate the value of the car in 5 years from now. And the C part is at what rate is the car depreciating. So here for the solution, we need to find 2 points, okay? The first point, when x equals 0, that'll be the original price, which is $25,035. So when x is 0, y is $25,035. So that's the first point. The second point, we get it from the last. I'm here towards the end of the sentence here. So in 4 years, the car will be worth $14,115. So this is my second point. We're going to get 4 for the x, and for the y, 14,115. So that'll be my second point. Now, since I found my 2 points, now I need to put the equation in slope intercept form. I need to find my slope. So again, we're going to do what we did earlier, find the equation of the line, given 2 points. So we got our 2 points from the information above. So we have y2 minus y1, which is 14,115 minus 25,035, and x2 minus x1, which is 4 minus 0. So this is my slope. We divide negative 10,920 divided by 4 is going to give us negative 2,730. So that's my slope. Now I need to find my b. b equals to y minus mx. So it's always wise to use the smaller point, which in my opinion will be the 0 and 25,035. So my y is 25,035, my x is 0, and my slope is negative 2730. We plug him into the formula. So we get 25,035. So then my equation will be, I found my slope, I find my b, we just plug him in. So my equation that we're looking for part A is f of x equals to negative 2,730x plus 25,035. That'll be the answer for A part. Now for B part, estimate the value of the car in 5 years from now. So here we're looking for f of 5, right? We're going to plug in 5 for every x. So if we put that in the calculator, it's going to give us 11,385. So the car, 5 years from 2016, will be worth $11,385 in 5 years from the original price. Now for C part, it states at what rate is the car depreciating, it means it's already, depreciating means it's going to be negative. So it's going to be, we're looking for the slope. So what is the slope, right? But since we know, depreciating means that it's negative, so we have to put the negative sign. So the car is depreciating at $2,730 per year. That's the answer for C. And that's that's it for problem number 3. So let's move on to problem number 4. For problem number 4, it says find the vertex, axis of symmetry, y-intercepts, and x-intercepts of the function f of x equals to x squared plus 10x plus 9. So like I tell my students, if it's in this form, we're going to use the ax squared plus bx plus c to find my vertex. Is going to be negative b over 2a, comma, f of negative b over 2a. This formula seems a little bit complex, like if it's complicated, but it's not really that hard. What it means here, for the x part of the vertex, I'm going to get the negative b over 2a, and then for the y part, whatever I get here, I'm going to plug I'm going to evaluate it at that number on the original equation. Let me show you what it means here, guys, so that way you know how to find the vertex. Also, the axis of symmetry, right, is going to be x equals to negative b over 2a. So I'm trying to show you how to find everything here. For the y-intercept will be the 0c. The y-intercept is actually visual. Without doing no work, you should be able to find the y-intercept. It's always the term that doesn't have a variable, just a constant. And then for the x-intercepts, we have to factor. Okay, so let's find the vertex first. So my a will be 1, and my b will be 10. So negative b over 2a, all we do is plug in the values for b and for a, which was 10 and 1. They will give us negative 5. Negative 10 over 2 will give us negative 5. That's the x part of the vertex. For the y part, we plug that in back to the original problem. So we're going to find f of negative 5. We plug that in into the x squared plus the 10x, right? We're going to plug it in for the x's. So we're going to plug in the negative 5 for the x's and also for the second x's. So if we evaluate here, this will give us 25 minus 50 plus 9 will give us negative 16. So my vertex will be negative 5, negative 16. Now, the axis of symmetry is always the x part of the vertex, right? So since we already found the negative b over 2a, so the axis of symmetry will be x equals to negative 5. That's the axis of symmetry. For the y-intercept, right, we know it's going to be 0c, so we know the 9 is like my constant. So it's going to give us 0, 9. That will be the y-intercept, 0, 9. For the x-intercept, we got a factor. So we're going to let f of x equals to 0 and solve for x by factoring. I did a workshop on factoring. I believe it was the second. Oh, no, I think it was the first week. You can go back and look at the video. That way you can know how to factor if you don't know how to factor at this point. But anyway, this sign tells me the signs are going to be the same, and the sign of the bx term tells me what they're going to be. They're both going to be positive. So we get the factors of 9. It'll be 9 times 1 and 3 times 3, and the sum must give us 10. That's why the factors are 9 and 1, which is x plus 9 and x plus 1. So we let them both equal to 0. So we get x equals to negative 9 and x equals to negative 1. So this is how you find the vertex, axis of symmetry, y-intercept, and the x-intercepts. Now number 5. Number 5, it's done in standard form. Here, again, we have to find the vertex, axis of symmetry, y-intercept, and x-intercept of the function. So on this one, everything is visual. For example, the vertex is visual, so is the axis of symmetry. And for the y and x-intercept, it's a little bit of work, but the vertex and the axis of symmetry, just by observing the function, we should know what it is. Okay, my vertex is going to be hk. So for example, here, right? So if it's negative here, if it's positive here, it's going to be negative here, because if it's negative here, right, on the formula, the vertex is positive. So in other words, it's always like reverse. So this is my vertex, and the axial symmetry will be x equals to h. And for the y-intercept, we're going to let x equals 0 and solve for y. And for the x-intercept, we're going to let y equals 0 and solve for x. Okay, so this is how we find each one of these that they're asking for: the vertex, axial symmetry, the y-intercept, and the x-intercept. So let's start with the vertex. The vertex is visual, right? Like I said, just by observing the function, you should be able to get the answer. So my vertex is going to be -3, -16. When you find the vertex, you also found the axial symmetry. Because x equals h, right? My h is -3, so it's going to be x equals to -3. Okay, again, that's a vertex, so this is my axial symmetry. Now, to find the y-intercept, okay, we're going to let x equal to 0. So if we plug in, g of x is also the same thing as y. So I'm going to plug in 0 for x. It's going to give us a 3. 3 squared will give us 9. 9 minus 16 will give us -7. Because this one here, you can do it without doing all the work. For example, if you let that equal to 0, right, at the beginning, then it'll be 3 squared. 3 squared is 9. 9 minus 16 will give us -7. But here I'm showing all the steps just in case you guys cannot do it with your heads from the beginning. Now the x-intercept, we let y equal 0, right? And we solve for x. So the first thing we're going to do, we're going to add 16 to both sides. So it's going to give us 16 equals to x plus 3 squared. The next step, we're going to take the square root of both sides to eliminate the square. I just put the x plus 3 on the left side and the 16 on the right side, right? And we take the square root of both sides. So this will give us x plus 3 equals to plus or minus 4, because the square root of 16 gives us 4. Now my next step is we're going to subtract 3 to both sides. So if we subtract 3 to both sides, it's going to give us x equals to -3 plus or minus 4. Now it's going to give us -3 plus 4 and -3 minus 4. So we get x equals to 1 and x equals to -7. So these are my x-intercepts, which will be -7, 0, and 1, 0. Now let's do number 6, how a quadratic function is applied in real life. So here's an example how it can be applied. On number 6, it states the revenue for McDonald's Corporation in billions of dollars for the years 2015. Because there's also a mistake here. It's supposed to be 2010 to 2015. Okay, it's supposed to be 2010. Can be approximated by the quadratic function r of x equals to -1 half x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So this is also a 3-part question. The first part, they want you to find the vertex. On the second part, they want you to, it says, in what year during this period was the revenue at a maximum? And for part C, what was the maximum revenue to the nearest $1 billion? So once you find the vertex, you also found the answer for part B and C, because the x part of the vertex will give you the answer for B, and the y part of the vertex will give you the answer for C. Okay, let me show you how it's done. So again, this is my vertex, the formula. So my A is equal to -1 half or -0.5, and my B is 13. So negative B over 2A will give us -13 over 2 times -0.5. This is going to give us 13, because -13, 2 times -0.5 will give us a -1. So -13 divided by -1 will give us a 13. Now for the y part of the vertex, we plug in 13 to the original equation. And if we do that and plug into the calculator, it's going to give us something like 27.5. So the vertex for part A is 1327.5. Okay. Now for part B, it's saying in what year during this period was the revenue at a maximum. So the answer here will be the x part of the vertex, right, which is 13. But if 2010 corresponds to the year 2000, if x equals 10 corresponds to the year 2010, Well, then x equals 13 will correspond to the year 2013. So the answer will be in 2013. Now for C part, it's going to be the white part of the vertex. What was the maximum revenue to the nearest $1 billion? So it's going to be, why is it going to be 28? Because to the nearest billion is going to be 27.5, rounds off to 28. So the answer for C part is the maximum revenue is $28 billion. Okay, let's move on to number 7. Solve the exponential equation. So here, I believe they want you to put them on the same base. Okay, so these are not the same base. So, I mean, I always tell my students to get the smallest base and then see if you can get the number on the right. If you square the 9, it's going to give us 81. And 81 does not equal to 27. So I know I have to find the same base for both the 9 and the 27. We know that 9 is the same thing as 3 squared. And 27 will be the same thing as 3 cubed. So now I'm going to replace 3 squared for the 9. Bring down the x. And I'm going to replace the 3 cubed with the 27. Right? And now we apply the exponent rule. The exponent rule. So right, so when we have a exponent raised to a power raised to a power, we multiply the powers. So this will give us 3 to the 2x. Right now we have the same base. So when you have the same base, you let the exponents equal to each other. So 2x equals to 3. We divide both sides by 2. So the answer should give us x equals to 3 over 2. Okay. And you can always check your work. Okay, so I'm going to plug in the 3/2 into the x. If you do that, right, if you put into the calculator, it's going to give you 27. So 27 equals to 27. That's how we can check our work. Okay, now I'm going to show you number 8. Number 8 is how you apply exponential functions into a like a real life situation. Okay, here number 8 says the assets in billions of dollars for a Prudential Financial Incorporation can be approximated by the function a of x equals to 315 e to the 0.056x, where x equals 7 corresponds to the year 2007. Find the assets for the following years. So for the year 2000, if x equals 7 corresponds to the year 2007, then x equals 0 will correspond to the year 2000. Okay, and for B part, x equals 12 will correspond to the year 2012. So for A part, I'm going to evaluate A of 0, which means I just plug in 0 for the x's. So we know e to the 0 will give us 1, so the answer will be 315 times 1 will give us 315. And remember, it's in billions of dollars, so it will be $315 billion. And for here I put here, guys, something good to know. The 315 is the initial value because time is 0. So every time the time is 0, that's when it's called the initial value. Now for B part, right, we're gonna evaluate at A at 12, which means we're gonna plug in 12 for the x's. And we can plug that into the calculator. It's gonna give us something like 616.8171575, rounded off to a nearest whole number, right, or to a nearest tens. Most of the times, in these problems, they round off to a nearest tenth. So this will give us $616.8 billion. It depends on your homework on the book or the My Math lab. If they want you to round off to the 10th place or to the 100th place, but in this case, I just rounded off to the nearest 10th, which is 616.8. Okay, now number 9. Number 9, I came out with this problem during COVID when I believe it was in January of in the year 2000 when COVID was really affecting the world, especially here in the United States. So I came up with a scenario so the students can actually know how exponential functions are used in real life. So number 9 states, a deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown to 128. So for A part, it says find the model of the form f of t equals to y naught b to the t power, with t equals 0 corresponding to the end of the month of January. If the trend continues for part B, about how many people will be infected by the end of the year? So for part A, I need to find y naught and b and plug them into the formula, and that'll be the answer for A. So how do we do that? Remember that I said on the previous slide that the initial value was time is 0, and the initial value here is y naught. Y naught is the amount present at time equals 0, which was, let's go here to the problem, which was 2. Okay, so there was 2 cases. So my y naught is equal to 2. If T1 corresponds to the end of February, right, because it's saying at the end of January, and we have to go to the end of April. So then T equals 2 corresponds to the end of March, and T equals 3 corresponds to the end of April. So from there, we get the other point, which is going to be 3, 128. Okay. So that means that I'm going to use a point 3, 128. So that means this is like my y. So f of 3 equals to 128, right? Which means y equals to 128 when t equals 3. So here we're trying to solve for b. So I'm going to divide both sides by 2. So it's going to give us 64 equals to b cubed. Now to solve for b, I'm going to raise it to the 1/3 power. That way we can have the b isolated. So when you have a power to a power, you multiply the power. So 3 times 1/3 will give us 1. And 64 to the 1/3 power will give us 4. So we know that b equals 4. So I found my y naught, which is 2, and I found my b. Now all we do is plug them into the formula. Right? So my y naught is 2 and my b is 4. Now I can find how many people will be infected at any given month. But for part B, it says at the end of the year, which is at the end of December, right? So from January all the way to December, there's going to be 11 months. So we're going to evaluate at f of 11. So that means we're going to plug 11 where the t is and just put in the calculator. Here, guys, we got 8,388,608 people will be infected by the end of the year. I know it wasn't the case because there's interventions and stuff. When there's like a virus, the health department, they intervene, right? And they intervene by having the social distance of 6 feet. And also the vaccines weren't implemented yet, but there were like hand sanitizing and all that stuff, right, that they did for intervention. That's how we eliminated for all these people to be infected. But if there was no intervention, about that many cases will be reported by the end of the year. Okay. The students, when we did this type of problem, the students were amazed, and I believe we did it before spring break because that's when their exam for this particular chapter was. And the students couldn't believe that many people could be infected. And sure enough, right, by the end of the year, there was a whole bunch of people infected all over the world. But this is a good example to show students how exponential functions are used in real life. Number 10. Number 10 and number 11, they're going to come, I believe, from chapter 5, which is a finance chapter. Number 10 reads, Gabriel invested his summer earnings of $3,000 in a savings account for college. The account pays 1.5 simple interest. Right away, simple interest, right away, you know that there's a certain formula for simple interest. What will be the value of the account after 2 years and how much interest did he earn? So this is a formula for simple interest. So FV stands for future value, PV stands for present value, the R stands for the interest rate, and the T stands for time. So from the problem, right? So the present value means how much money was invested. So here it says $3,000, so that's my present value. Anyway, we're looking for what will be the value of the account after 2 years, right? So we're looking for the future value. My interest rate will be 1.5%, right? But you have to convert it to a decimal. So you move it to the left to decimal places, and you drop the symbol. So R is equal to 0.015. And the time is 2 years. So we plug everything to the formula, right? There's my present value. There's my interest rate, which will be 0.015, and my time is 2 years. We put into the calculator, it's going to give us something like 3,090. So that's how much money was in the account after 2 years. So for the second part, right, it says how much interest did he earn. The interest is the future value minus the present value. The future value was 3,090, and the money invested, the initial money was 3,000. So we subtracted to find how much interest did he earn, which was $90. So in 2 years, right, the value of the account after 2 years was 3,090, and the interest that he earned by having the account by having the money in that account, he earned $90 extra, that's how much interest he earned. Okay, now number 11. Number 11, it says you deposit $9,000 into an account at your bank that pays 2.5% interest semi-annually. How much money will be in your account after 10 years, and how much interest did you earn? So again, here, guys, where it says like compounded, this right here means compounded, right? So compounded is going to be the section 5.2, which is a different formula than simple interest. So this is a formula that we're going to be using. But I like to use this formula instead because it's easier. It's easier to work with in the calculator. So let me show you what everything means here. Okay. So I need to find 7 things, right? The future value, the present value, my R, the interest rate. The M stands for how many times it's compounded per year. T is time. The I replaces the R divided by M, right? On the first formula. So R divided by M is the same thing as I. And the M times T is the same thing as N. So from this problem, we're going to extract the info and put it on its right location. So for example, here, if you read at the beginning, you deposit $9,000, right? So this is how much money you deposit right now, which is the present value. And how much money will be in your account after 10 years. So we're looking for the future value. That's what we're looking for. So the present value is the money that you would deposit right now at the present time, which is 9,000. My interest rate will be 2.5%, but remember that you have to convert it to a decimal, so you move the decimal place 2 places to the left, and you drop the symbol. So it should give us 0.025. And the M is how many times it's compounded per year. So here interest semi-annually means twice, right? So it's going to be 2, M equals to 2. And the time is 10, so it'll be 10 years. Now the I is R divided by M, which will be 0.025 divided by 2 will give us 0.0125. And the N is M times T, which will be 2 times 10 will give us 20. So we just plug into the formula and let the calculator do the work for us. It's going to give us, 11,538 and 34 cents. Okay. So after 10 years, it will be $11,538.34 in the account. So how much, for the second part, how much interest did you earn? So again, right? So again, we're going to subtract the future value for what we earned in those 10 years minus the money invested. Minus the 9,000 is going to give us something like $2,538.34. So this is how much money extra we earn just by having in the account. By opening an account and having that money deposited into that account, paying that 2.5% interest, compounded semi-annually for 10 years. So I like to show these type of problems to my students because that way they're aware that that math and money they go together, especially in this chapter 5, which is a finance chapter. which is a finance chapter. Okay, now let me continue with number 12. Number 12 is solved by graphing. Okay, so here they're going to give you two equations. So I think this is chapter 6 where you're solving by substitution, by the elimination method, and also by the Gauss-Jordan method. But here I'd like to show you first by graphing, and then we'll do the number 13 by the elimination method. So by graphing, right, this is equation 1. We call it, for equation 1, right, my slope is 3.031. Why do we put it into a fraction? Because we're going to go, this means, right, this is a rise over the run. So it's going to go 3 up and 1 to the right. From where? From the B, which is my y-intercept. So this is also my starting point, 0, 0, -6. So I'm going to start at 0, -6, which is down here, way at the bottom. Then I'm going to go up 3. Let's see, 1, 2, 3, and 1 to the right. And then all we do is connect the 2 points. So this is my line for the equation number 1. Now for equation number 2, we're going to put it in the proper form, which is the slope-intercept form. This way, we can find my M, my slope, and my B, and actually graph it the same way. So to start off, I need to isolate, have the y by itself. So we're going to add 5x to both sides. Right, so we add 5x to both sides, we're going to get negative 2y equals to 5x minus 10. We divide both sides by negative 2. So we get y equals to negative 5/2 x plus 5. So then that means that we're going to go down 5 and 2 to the right. From where? From my starting point, which is my B, which is the y-intercept. So the 0, 5 is my starting point. So let's go to the graph. So let's go to 0, 5. It's going to be up here, 0, 5. Then we're going to go down 5, 1, 2, 3, 4, 5, and 2 to the right, 1, 2. That's my point. So we connect the 2 points, and that's my line for equation number 2. So the answer will be where both lines intersect, which will be 2, 0. So that's my solution will be 2, 0. Now, consistent independent system, that's a notation, I believe, for the 13, 14. I believe it's more common in the 13, 14 book, which is a pre-cal. But consistent independent means that there's going to be only one solution. Okay, now let's do another one, number 13, but let's solve it by using by elimination method. So by using this method, they both have to be in proper form. They both have to be in the form ax plus by equals c. Okay, equation 1 is not in that form yet, right? Because it has to be the ax plus by equals c, so I need to put it in proper form. So I'm going to add 2y to both sides. You see now it's in proper form. X plus 2y equals to 19. So we got both equations right. So here's where I tell my students that what's easier to eliminate, the x's or the y's. In my opinion, it will be easier to eliminate the x's because I only have to multiply equation 1 by negative 4. Why do we use negative 4? Because negative 4 times x will give us negative 4x, and then when I add it to the second equation, they'll be eliminated because negative 4x plus 4x will give us a 0. But you have to do multiply by both sides of the equation because this is how you do math. You cannot just multiply times the first term. In mathematics, you have to use proper techniques. And when you multiply, you can multiply both sides of the equal sign by the same number and it will not change it. Because it can always be reduced back to the original. But anyway, negative 4 times x will give us negative 4x. Negative 4 times 2y will give us negative 8y. And negative 4 times 19 will give us negative 76. So the second equation, we just bring it down how it is. Right? So the x's are going to be eliminated. So negative 8y minus 3y will give us negative 11y. And negative 76 minus 1 will give us negative 77. Now we divide both sides by negative 11. So then we get y equals to 7. Once you get once you get the y value, we need to find the x value. So we can go back to either 1 or 2 and plug in the 7 for y and solve for x. Here, in my opinion, guys, it's easier to go to equation 1 because the x is already isolated. So let's go to equation 1, and we're going to plug in 7 for the y-is. It will give us x equals to negative 14 plus 19, x equals to positive 5. So what's my answer, or my solution? Will be 5, 7. So these two lines, they intersect at the 0.57. That's what that's what it means. Okay, now how do we apply it in real life? This is how you apply it in real life. It says a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So here, guys, the solution, we need to find two equations. Okay, so we're going to use people with people or money with seats with seats, or people with people and money with money. What does that mean? This is what it means. Okay, we're going to let X be the adult tickets, and then Y be the children's tickets. And it's going to be a total of 200 seats, right? So the first equation is going to be X plus Y equals to 200. Now we're going to use the money with money. So for example, let's see here, the adult tickets are $8. Since X represents adults, then this is going to be 8X. In a similar manner, the children's tickets are worth $5. Since Y represents the children's seats, so it's going to give us 5Y. And what was the total income? The total income was $1,435. So here's where we get our second equation, which will be 8X plus 5Y equals to 1,435. Now we got our both equations. So since they're both set up in the proper form, in the AX plus BY equals C, we're going to use the elimination method. So what's easy to eliminate? Here it doesn't really matter, but I believe I'm going to eliminate the x's. So to eliminate the x's, I need to multiply the first equation by negative 8. And again, why negative 8? Because negative 8 times x will give us negative 8x. And then when we add it to the second equation, to the 8x, they're going to be eliminated. Okay, but I have to multiply negative 8 times every term. The result is negative 8x minus 8y equals to negative 1,600. Equation number 2, we'll just slide it over, right? The x's will be eliminated because negative 8x plus 8x will give us a 0x. Negative 8y plus 5y will give us a negative 3y. So negative 3y equals to negative 165. We divide both sides by negative 3. So we get y equals to 55. Now I need to find the x value. So it's easier to go to equation number 1. But we know the y is 55. We'll plug it into the equation where the y is. And then we subtract 55 to both sides, giving us x equals to 145. So x equals to 145 and y equals to 55, right? But the question was how many adults and how many children were in the audience. So since variable x corresponds to adult seats and the variable y corresponds to the children's seats, so there were 145 adults and 55 children. And again, this is how you apply linear systems of equations in like in real life situation. Okay, let's go to number 15. Number 15 is the Gauss-Jordan method to solve systems. So this method, I kind of modified it from the original, from the book. I just, instead of having too many matrices, I only have 3 matrices, which I'm going to use step 1, step 2, and step 3. So the object for step 1 is that on row 2, I need to eliminate the 2, make 2 a 0 and the negative 1 a 0, which is a second row, first column, the 2, and the third row, first column, the negative 1. I need to make those zeros. So step 1, row 1 stays the same. So I need to change row 2 and I need to change row 3. So I'm going to multiply negative 2 times row 1 and add it to row 2. Then I'm just going to add row 1 plus row 3, right? And now that guarantee that it's going to give me a 0 where the negative 1 is. So it's going to be row 1 plus row 3. And here's my work. The work is step 1, A and B, right? So negative 2 row 1, right, equals to negative 2 times row 1. It's going to give us negative 2, negative 4, 2, and negative 12. When I add it to row 2, right, row 2 will give us 2, negative 1, 3, and 2. So when we add them, it's going to give us 0, negative 5, 5, and negative 10. You see, we got the 0 that we wanted, but like I tell the students to try to simplify as you go along. Here we can simplify by dividing everything by negative 5. So if we do that, it's going to give us 0, 1, negative 1, 2. So this becomes my new row 2. Now for the second part of step 1, we're going to add row 1 plus row 3. This is my row 1, right? This is my row 3. And when you add them, it's going to give us 0, 1, 0, 1. So I'm going to replace row 3 with 0, 1, 0, 1. Okay, so after I do that, then I'm done with step 1. Now I need to go to step 2. I need to do step 2 here. So for step 2, I'm gonna have to make where the 2 is in row 1, I need to make the 2 a 0, and also in row 3, I need to make that a 0. So step 2, we're gonna keep row 2, right? So row 1's gonna change, and row 3's gonna change. So I'm gonna multiply negative 2 times row 2 and add it to row 1. Then I'm gonna multiply negative 1 times row 2 and add it to row 3. And here's my work. Right, negative 2 row 2 plus row 1. So negative 2 row 2 will give us 0, negative 2, 2, and negative 4. When I add it to row 1, right, we just bring row 1 over, it's going to give us 1, 0, 1, 2. So that's going to be my new row 1. And for the second part on step 2, I'm going to multiply negative 1 times row 2, which will give us a 0, negative 1, 1, and negative 2. I'm going to add it to row 3. So row 3 was 0, 1, 0, 1, right? So when we add them, it's going to give us 0, 0, 1, negative 1. So this is my new row 3. Now I need to do one more step, right? The last step, which is step 3, I need to make row 1, the third column, a 0, where the 1 is, and also row 2, column 3, where the negative 1 is, I need to make that a 0. So I need to use row 3. So row 3 stays the same, right? So I'm going to multiply negative 1 times row 3 and add it to row 1. Then I'm just going to add row 3 and row 2. Okay, so here's my work. So negative 1 row 3, we're going to multiply negative 1 times all the values in row 3, which is 0, 0, 1, negative 1. Is going to give us 0, 0, negative 1, 1. When I add it to row 1, all I do is bring row 1 over, which is 1, 0, 1, 2. When we add them, it's going to give us 1, 0, 0, 3. So this is my new row 3. Row 1, I mean. Now, I'm going to add row 3 and row 2. There's my row 3, and here's my row 2. When I add them, it's going to give us 0, 1, 0, 1. That's my new row 2. So my solution is x equals to 3, y equals to 1, and z equals to negative 1. And if this is the first time that you've been in this, the first time that you see, that you join Friday Happy Hour, this can be a little bit confusing. I believe in the previous, workshop where you solve systems or linear equations, I explained that in detail, step by step. So maybe you can go back to the recording and actually get a better feel for this type of problem, because these are a little bit challenging. Okay. Now here it says perform the indicated operation. We're going to multiply negative 4 times matrix A. So negative 4 times matrix A, it means I'm going to multiply negative 4 times every element in the matrix. it's going to be the same thing as negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. It's going to give us 8, 0, negative 20, and negative 12. That's negative 4 times matrix A. Now for B part, I'm going to multiply 5 times matrix B. In the same manner, I'm going to multiply 5 times every element in B, which is 0, 2, 4, negative 6. So here, right, it's going to be 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. So it's going to give us 0, 10, 20, and negative 30. Now for part C, right, they want you to find negative 4a plus 5b. So negative 4a, we already solved it, right? So it was the first part here in part A. So the answer was 8, 0, negative 20, negative 12. And the 5b was in part B, which was 0, 10, 20, negative 30. So when you add matrices, right, they have to be the same size in order for you to add them or subtract them. So here it's going to be 8 plus 0, and then 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. So the answer will be 8, 10, 0, and negative 42. This is the answer for part C, which is negative 4a plus 5b. Okay, now multiply matrix, multiply B times A. So in order to multiply matrix, matrices, right? So this is the size of B, the size of A. The two numbers in the middle must match. If they do, that means you can actually multiply the matrix. If these were different numbers, right, then the multiplication cannot be applied if the numbers are not the same, the inner numbers. So since we have a match, yes, we can multiply them. And the answer or the solution will be a 2 by 3 matrix, which is the outer. Again, the inner tells you that you can that we can multiply them or not. If they're the same, we can multiply them. And the answer will be the outer, the outer size of the matrix, which would be a 2 by 3. Okay, now this is, I'm going to do it in a few steps. Okay, so step 1, I have to multiply the first row times every column in A, right? So 1 times 2, and then add it to 0 times 4. So it's going to give us 2 plus 0. The answer will be 2. So 2 will go in the first slot of the matrix here on the first column, first row, column 1. Now step 2, I'm going to multiply again the same row, which is a 1, 0, but now I'm going to multiply it times the second column, which is in red, the 0, negative 2. We're going to have 1 times 0, then add it to 0 times negative 2. It's going to give us 0 plus 0. The answer will be 0. So the 0 goes on the first row, second column. Right, we still have to do another column. So for step 3, again, I'm going to multiply the first row, but now times the third column. It's going to give us 1 times 5 plus 0 times negative 3. The answer is 5 plus 0. The answer is 5. So 5 goes on the first row, last column, which is the third column. Since we don't have no more columns to multiply by the first row, now the step 4, we're going to use the next row, which is row 2, which is highlighted in blue. Now I'm going to repeat the process. I'm going to start by multiplying times column 1. 4 times 2 plus negative 2 times 4. It's going to give us 8 plus negative 8 will give us 0. So 0 will go in the second column, on the second row, first column. Now comes step 5. So I'm still multiplying the second row times now the second column, which is going to be in red. So 1 times 0 plus 0 times negative 2. This is 4 times 0, and negative 2 times negative 2 is going to give us 0 plus 4. It will give us 4. So that's going to be the second row, second column, the 4. Now my last step, we're going to multiply the second row, which is a 4, negative 2. But now we're going to multiply it times a 5, and the negative 3, which is the third column. 4 times 5 plus negative 2 times negative 3. So it's going to give us 20 plus 6 will give us 26. So this is my solution. Will be 205 and 0426. This is how you multiply matrices. Okay, now we're doing number 18. Use the given information to find the following. Let U, which is a universal set, equals to the elements A, B, C, D, E, 1, 2, 3, 4, 5. Set X equals to the elements A, B, 1, 2, 3, and set Y equals to the elements B, D, 1, 3, 5, and set Z equals to the elements B, 2, 3. List the members of each of the given sets using set braces. Okay, now, since we have to find the complement of X and a complement of Y, let me do it here on the right side. So the complement of X means that you're going to go to the universal set, and whatever the X is, it won't be that. So for example, not A, not B, not 1, not 2, not 3. So what's left will be C, D, E, 4, 5. Same thing with the Y, all right? Y, the complement of Y means not Y, or complement of Y means the same thing. So we're going to go to the universal set. So not B, we can scratch it off. Not D, not 1, not 3, not 5. So what's left was A, C, E, 2, and 4. And this is set Z. Okay, now let's find A and Y, or A or X intersects Y. Okay, we're going to go to X and Y, the X set and the Y set. The intersection, or the and symbol, means what do they have in common? They have in common a B and a 1 and a 3. So this is my intersection of X and Y is B1, 3. Okay, now for B part, it says X or Y. The U symbol means or X or Y, or it also means union. Okay, like I tell my students, this is what you do here is you put every element of set X, which is A, B, 1, 2, 3. Then we're going to go to Y, and if it's already there, we don't write it again. For example, is a B already there? Yes, it is, right? So we don't write it again. The D is not there, so we need to put the D. The 1's already there. The 3's already there. How about the 5? The 5 is not there yet, so we're going to put the 5. So, or else you can do it another way. You can put both elements, the elements of both sets, and then you take, if they repeat, you erase one out. You erase one out. That's another way to get the answer. But like I tell my students that you put every element on the first set, and then you go to the second set, and if it's already there, you don't put it again. And if it's not there, that's when you put it. Okay. Now for part C is called the complement of X, right? Which I already got over here on the right side. So the answer will just be CDE 4, 5. Now let's do the complement of X intersects the complement of Y, right? So we have them here on the right. Remember that the upside down U means and, or what do they have in common? They have in common a C. They have in common an E and a 4. So that's my answer. Okay, now let's do part E. The complement of X intersects Z. So let's go here on the right. What does a complement of X and Z have in common? This is C, D, E, 4, 5. They don't have nothing in common, so it's going to be the empty set. Right? These two means the empty set, nothing in common. Okay, now let's do part F. And all these comes from the book, from the homework. Okay, let's do part F. Here we have to follow PEMDAS, right? So first we have to do the parentheses. So what does the set Y and Z have in common? Let's go to Y here on the right. Y and Z have in common a B and 3. Right, so the intersection of Y and Z is B3. Now let's do how I said it earlier, right? Like example B. So we're going to go to the X set. We're going to put everything there from X, which is A, B, 1, 2, 3. Then we go to the next set, which is a set containing the elements B and 3. If it's already there, we don't put them again. You see, is a B there already? You're right, it's already there, so we don't write it again. How about the 3? It's also already there. So then my answer would just be set X, A, B, 1, 2, 3. Okay, now this is number 19. Number 19, I know it's already past a little bit of time, but I believe I have like four more examples to do. Number 19 says 60 people were contracted and responded to a movie survey. The following information was obtained. 6 people like comedy, dramas, and science fiction. 13 people like comedies and dramas. 10 people like comedies and science fiction. 11 people like dramas and science fiction. 26 people like comedies. 21 people like dramas, and 25 people like science fiction. So here it's like a 4-part question. The first part, they want you to use a Venn diagram to illustrate the survey's results. So let's do part A. We have to do a Venn diagram. So I'm going to let each one of these circles be a set, right? But first of all, there were 60 people, so the 60 is like the union. It's like the universal set. I'm sorry about that. It's 60 universal set. So we're gonna let C be comedy. So let's let this set be my C. We're gonna let D be dramas. So let's have the one here towards the right be my D set, and then let's let S be the science fiction, which would be the one on the left. Now here's where you start, guys. Here in red means that's what they all have in common, right? 6 people like comedies, dramas, and science fiction. So that means where do they all intersect? All 3 sets, right? So this is where you start. They all intersect here where the mouse is. So this is going to be 6. Okay. Then let's go to the second part. It says 13 people like comedies and dramas, means C intersects D. So this is my set C, and this is my set D. So they intersect on this area right here that I have my mouse on. So this has to be 13. So we already got 6, so this must be 7. Okay. Now let's do 10 people like comedies and science fiction. So where's the C intersects S, which is 10? This is my C, this is my S. So this area has to be equal to 10. We have 6, right? So this has to be 4 then. The 4 goes there. Then we have 11 people like dramas and science fiction. So D intersects S will be this region here. So this region must be 11. We already got 6, so this must be equal to 5. Now they're saying that set C has 26 people that responded to the movie survey. So all this must equal to 26. This whole set C. We got 4, we got 6, we got 7, right? That's equal to 17. So then 9 must be here on this region here, because all this must equal to 26. In a similar fashion, D, which is dramas, is 21. So all this region must equal to 21. I already got 11 plus 7 will give us 18, so this will give us 3 in the outside. And finally, for the science fiction, it's 25. So all this region must be 25. We got 4, we got 6, that's 10. This is 15, so this must equal to 10. Okay, but we're not done yet, right? Because now we have to, they're supposed to be 60. So how many were here on the outside the circles? Let's find out. So we're going to add all these and subtract it from 60. You see, we got 9, 7, 6, 4, 3, 5, 10. We got them from here. So it's equal to 44. So 60 minus 44 will give us 16. So 16 goes in the outside, which is in blue. So this is the answer for part A, my Venn diagram. Now let's do part B. How many people surveyed like comedies, but neither drama nor science fiction? So let's go to comedies, right? So they're talking about this right here, comedies. But they don't like dramas nor science fiction, so not these. So the answer will only be 9. Look at part C. How many people surveyed like dramas and science fiction, but not comedies? So let's go to dramas and science fiction. You see dramas and science fiction, right? So it's going to be these two, but not comedies, so not these. So the answer will be 10 plus 5 plus 3, which will give us 18. So 18 people like dramas and science fiction, but not comedies. How many people like none of the movies, which is a value or the number outside the box, outside the circles, which is 16. So the answer was 16. That's how you do these type of problems. Okay. Now number 20. A single playing card is drawn at random from an ordinary deck, an ordinary 52 card deck. Find the probability of the drawing. A queen, a diamond, a red card, and a face card or an ace. So here's are the cards. Each card, there's 52 total. There's 13 clubs, 13 spades, 13 hearts, and 13 diamonds, with a total of 52. Okay, now there's 26 black, there's 26 red. And there's going to be 3 face cards. The face cards are the ones that have a face. So for example, here, each suit has 3 face cards, the jack, the queen, and the king. Now with that said and done, let's answer the questions. So this is what you use, right? For probabilities, it's going to be P of E equals to the number of the event over the sample space. So the sample space for the cards will always be 52, right? Because there's 52 cards. Now let's do A part. The probability of drawing a queen. So it's going to be the number of queens is going to be 4, right? Because there's 4 in each suit. There's 4 in the clubs, and the spades, the hearts, and the diamonds. So there's 4. The sample space is 52. So 4 over 52 will give us 1 over 13. That's the answer for part A. For part B, diamonds, right? So how many diamonds are there? There's 13 diamonds. So it's going to be 13 over 52, which will give us 1/4. For part C, right, the probability of a red card, there's 26 reds, right, and 26 blacks. So it's going to be 26 over 52, which will give us 1/2. Okay. Then finally, for part D, a face card or an ace. How many face cards are there? There's going to be 12, right, because there's 3 for each suit. So 3 times 4 is 12. And how many aces? There's 4 aces because there's 1 ace for each suit, which will give us 16. So it'll be 16 over 52 reduced to 4 over 13. That's how we do probabilities with cards. Now let's do 21. Suppose 2 fair dice are rolled. Find each of the given probabilities. The first die shows a 2, or the sum of the result is 6 or 7. So here the key word is going to be or, right? So we're going to use, this is the probability of A union B, or A or B equals to the probability of A plus the probability of B minus the probability of A intersects B. So we're going to let the first event, which is the first die shows a 2, be A. Then let B be the event that the sum is 6 or 7. Okay, so here's all the possible combinations that you can roll a die. There's going to be 36 is my sample space, right? Because it's 36, there's 6 across and 6 down. So 6 times 6 is 36. So for the first die to show a 2, right, it's going to be this in red, which is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. So there's going to be 6. Now for the die, for B, for the die to be 6 or 7, it's going to be 11 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is a sum that has a 6 or a 7. So now the probability of A will give us 6 over 36, plus the probability of B will give us 11 over 36. Now where do they intersect? They intersect, right? So minus the intersection will be 2, 4 and 2, 5, which is 2. So it's going to be minus 2 over 36. So the answer will give us 15 over 36, which we can be reduced to 5 over 12. So this is a solution for part A. Okay, now for part B, right, it said the sum is 11, or the second die shows a 5. So again, the sample space is 36. So 11 will be here at the corner, right? So 11 will be here. There's only 2 of them. And the second die is a 5. The second is a 5, so it's going to be here across. The second die is a 5. That'll be my B. So then, right, so then it's going to give us 1, 2, 3, 4, 5, 6. Okay, now the intersection will just be 1 right there where they intersect. Let's put into the formula. So it's going to be 2 over 36 plus 6 over 36 minus 1 over 36. The answer will be 7 over 36 is my solution. Okay, that's how you work these type of problems. Now, 22. For many years, the state of California used 3 letters followed by 3 digits on its automobile license plates. So here's my scenario. Note, 26 letters are in the alphabet and 10 digits make all the numbers. So here's part A. How many different license plates are possible with this arrangement? So these are my letters and these are my numbers. So there's 26 letters, right? There's no restriction. So it's going to be 26 times 26 times 26 times 10 times 10 times 10. If you put that in the calculator, it's going to give you something like 17,476,000. Now let's do part B. When the state ran out of new numbers, the order was reversed to 3 digits followed by 3 letters. How many license plates were then possible? Right, so these are the digits now, these are the letters. So again, it's going to be 10, 10 times 10 times 10, and 26 times 26 times 26. Even if the order is switched, right? I mean, multiplication is it's commutative, so it doesn't matter. We're going to get the same result as part A, which is 17,576,000. Now let's do part C. Several years ago, the number described in parts B were also used up. The state then issued plates with 1 letter followed by 3 digits and 3 letters. Here's my scenario. So the first is going to be a letter, then 3 digits, and then 3 letters. So again, 26 letters, and then going to be times 10 times 10 times 10 times 26 times 26 times 26. Look what happens when they add 1 letter to the answer in part B. It increased to 456,976,000. So it increased by what? By 440 million by adding 1 letter. Isn't that amazing? Okay, now we're down to the last 2 problems here, I believe. We're down to permutations and combinations. This is a formula for permutations. It's NPR, which is n factorial divided by n minus r factorial. And the clue words that is going to be permutation, it can be arrangement, schedule, order, or order matters. Those are the clue words that it means it's going to be permutation. From combination is going to be NCR, which means n factorial divided by parentheses n minus r factorial times r factorial. And the clue words are group, committee, set, sample, or order does not matter. So let's see what number 23 has to offer here. It says a lottery game requires that you pick 6 different, I forgot to put here numbers, 6 different numbers from 1 to 99. If you pick all winning numbers, you win $4 million. How many ways are there to choose 6 numbers if order is not important? So again, for part A, if order is not important, it's going to be combination. That's going to be 99 combination 6. The answer will be 1,120,529,256. For part B, the order matters. So it's going to be permutation. So it's going to be 99 permutation 6 is going to give you 806,791,064,320. What a big difference, right? From order matters, which is permutation, to order does not matter, which is combination. It's a big difference there. Anyway, I believe we have 2 more. This is number 24 and 25, and we'll be done. In exercise 59, you pick 5 out of 6 numbers correctly, you win $5,000. In how many ways can you pick exactly 5 of 6 winning numbers without regarding order? That means it's going to be combination, right? So now, remember 5 out of 6. So 5 out of 6 numbers, is going to be 6, combination 5. But remember, with a lottery, we need to pick 6 numbers from 99. So in this case, right, so then I need to pick 1, right, because if we chose 5 correct numbers, right, we still need to get another one to make it to 6. Since we have 6, and we have to have 99, so that's why it's going to be 93. So this one is going to be 93, combination 1. You see the 2 in the outsides must equal to 99, and the 2 in the inside must equal to 6. Okay. Now 6 combination 5 is going to give you 6 times 93. The answer is 558. Okay. Now we're down to the last problem here. A financial advisor offers 8 mutual funds in high risk category, 7 in moderate risk category, and 10 in the low risk category. An investor decides to invest in 3 high risk funds, 4 moderate risk funds, and 3 low risk funds. How many ways can the investor do this? So it's going to be a combination, or it does not matter. So from 8, we want to invest 3, right? So it's going to be 8 combination 3. The second part, in the 7 moderate risk, they want to invest 4. So it's going to be 7 combination 4. And then in the 10 and 10 in the low risk, right? So they're going to invest in 3. So it's going to be 10 combination 3. So 8 combination 3 is 56, 7 combination 4 is 35, and 10 combination 3 is 120. We multiply them out, and that's my result, 235,200. That's how many ways you can select the funds. Okay, I believe that's it for this final exam review. I wish you all good luck in this exam, and thank you for staying a little bit extra. Thank you.
Thank you, everybody. Thank you, Mr. Azasi, for presenting for us today. We hope you have good luck on y'all's exams. We'd like to take a moment to invite you to next week's session, which will be just the 1 o'clock session, free learning resources for TSIA2 and TEAS test prepping with the PREP program. Thank you and have a wonderful weekend.